Now let's complete the rest of the test. Figure 2.1 shows a tennis ball approaching a tennis racket. The tennis ball hit the racket at speed of, this is initial speed, so initial speed u equal 52 meter per second. The average force on the ball during the time that is in contact with the racket is, this is the force, 350 Newton. The speed of the ball after it leaves the racket is 25 meter per second in the opposite direction. What it means in opposite direction, it means it will be negative sign, okay, 26 meter per second, because what is the meaning of moving in opposite direction? It means if u is positive, v should be negative, okay. The mass of the ball is, he gives you mass of the ball 58, but it is in gram. So the first step, you should convert mass to kilogram. 58, okay, divided by 1000, it will be 0.058 kilogram. This is the first step, because unit of mass should be in kilogram if you want to solve the problem, because you have force with Newton, so you have to convert. Calculate the change in momentum of the ball while it's in contact with the racket. He asked to find the change in momentum. Change in momentum equal mass multiply change in velocity. So mass, also you can write it like this: mass multiply v minus mass multiply u. Both are right, okay. So mass now after converting is 0.058 multiply change in velocity. Final velocity is negative 26 minus initial is 52. So what is the answer? The answer will be negative 4.524. Ignore the sign, okay. So the answer will be 4.524. What is the unit? Kilogram meter per second. State an equation which define impulse. Impulse equal force multiply time. Calculate the time that the racket is contact with the ball. If you ask it to find time, as you see, we have force and we have a change in momentum, so we can use force multiply time equal change in momentum. If you want to find time, you will divide change in momentum over force, so it will be 4.524 divided by what? Force which is 350 Newton. So time will equal 0.013 seconds. Okay. Figure 2.1 shown a dummy of mass 70 kilogram. So here the given mass is 70 kilogram. Used in a crash test to investigate the safety of a new car. The car approached a solid barrier at speed, so this is initial speed 20 meter per second. It crashes into a barrier and stops suddenly, so final is 0. Calculate the momentum of the dummy immediately before the crash. It means momentum equal mass multiply u, because he said before the crash. Okay, so 70 multiply 20 equal what? 1400. What is the unit of momentum? Kilogram meter per second. Okay, let's move to the next. Figure 1.1 and 1.2 shows a speed time graph for two objects each moving in a straight line. Speed time describes the motion of the object shown by the graph in figure 1.1. Figure 1.1, this graph show a constant acceleration because gradient is constant, and gradient refer to acceleration. So describe motion in this figure: constant acceleration. Okay. Now describe the motion of the object shown by the graph in figure 1.2. In figure 1.2, as you see, acceleration is decreasing because gradient decrease. So it will be decreasing acceleration. Okay. On a day with no wind, a large object is dropped from a tall building. This is a free fall. The object experiences a resistance. It means we have a resistance. So it is free fall with presence of a resistance during its fall to the ground. State and explain in terms of force. You have to mention two forces in all your answer. How acceleration change during the fall. So you will start with at the beginning, the only force acted on the body, on the object, which is object, yes, is weight. So the net force is weight, and acceleration equals g. After a while, speed increase. As speed increase, air resistance increase, and net force will decrease. So acceleration follow net force will decrease until when? Air resistance balance with weight. In this case, net force becomes zero and acceleration equal what? Equal zero. This is what happened to the acceleration while changing in net force. Okay, and this is the last question. See you in the next test, inshallah.